Yo, Chuck.
Hey, what's going on YouTube? In this video, we're going to go over how to find all the prime numbers up until a specific number. So let's say I had the number 10. I want to find all the prime numbers up until 10. That would be 2, 3, 5, and 7, for instance. So that is our problem statement. Initially, I'm going to show you a naive solution to do this. Then I'm going to show you the Sieve of Eratosthenes solution, which is a Greek algorithm to find prime numbers up until a specific number. So stay tuned. This should be a pretty fun lecture. All right, let's get started. Okay, so the first thing I want to do for finding all the primes up into a range, I can just make a function that finds if a number is a prime number or not. So I'm going to make a function. I'll call it isPrime. It's going to take a number. And then all I'm going to do is loop through, I'm going to set a variable I. I'll say let I equal 2. And then while I is less than number, I'm going to increment I. So why am I saying I is equal to 2? Because 0 and 1 are never prime numbers. So we can just skip them altogether. Okay? And then within this code block, I'm going to be iterating up until the number itself, and I'm going to do an if statement. If number modulo I equals 0, return false. So if you can imagine, this for loop, I is going to start at 2, and then it's going to end at 1 less than whatever the number is. So basically, all the values of a not prime number are going to be covered with I. So if num modulo I ever equals 0, that means that I can evenly go into the num, which means that the number is not a prime number, right? So I'm going to return false if that's the case. But if that if statement isn't triggered, then it is a prime number, so I'm going to return true. Okay? Save that. So now I'll console.log is prime, and then I'll pass in a number that we know is a prime number, like 5. Okay? Let's log this guy out real quick. So yes, it's saying that 5 is a prime number. Let's do a number that we know is not a prime, like 6. False, correct. Okay, how about 99? That's not a prime number. So false again. Let's do one more prime just to make sure. I'll pass in 7. And that is true. Okay, so it looks like our function to find prime numbers is good. So we want to find prime numbers up until a specific range. So what we can do now is come in here and say up to range, make a function, and then we'll pass in yet another number. So the way we can look at this is we can do a while loop and we can decrement num, right? So we'll say while num is less than or equal to 2, we're going to decrement num. And let me show you what we're going to do here. So I'll say if, and now I'm going to use that function we just made to test if a number is prime or not. I'll say if is prime, whatever the value of num is, we need to grab it and put it into some result container. So I'm going to make a array. I'll call it result. So I'm basically saying, hey, if the number is prime or not, or if it is prime, I want to put it in my result array. So I'll say result.push, whatever the num is. And then at the end, I want to return all the prime numbers. Because you'll notice we put in that initial number of, let's say, 10. 10 is going to be decremented each iteration of this loop. And it's going to check each step of the way, is the number a prime or not? So initially you're going to have 10, is that a prime? No. Then 9, is that a prime? No. 8, no. And then you're going to get 7, yes. And then it's going to push 7 into our result array. So let's console log this out. So say up to range, and I'll pass in 10. Let's see what happens here. Looks like we're not returning anything, so we're not actually pushing anything to up till range, which isn't good. Let's see why that is. Oh, this should be while num is greater than or equal to 2. Right? There we go. Okay, so you can see all the numbers. For readability purposes, I'm going to sort this. And there you have it. Those are, in fact, the prime numbers up until 10. Let's do a larger number like, let's say, 30. And here, we need to sort an ascending order. It's still not sorting an ascending order here. So let's do, we can pass in A and B, and then return A minus B. This is just comparing values inside of the result array numerically, and that should work. Okay, there we have our values in ascending order. That looks good. That's from 1 to 30. Recall that 0 and 1 are never prime numbers. That's why we are just skipping and starting at 2 in our for loop for the is prime, and then also that's why we're saying num, while num is greater than or equal to 2, decrement num, right? So that is the naive solution, and you might have thought of this intuitively, like, oh, I could just check, if a number is a prime up until a certain range, and then decrement the number in like a while loop or a for loop or whatever, and then that would give me the answer. Yes, this is a possible solution, but let me show you the Sieve of Eratosthenes, which is also another acceptable solution. So let's check that out. All right, so the first thing I'm going to do is make a function called sieve. It's going to take a number or a number I want to go to until I can find all the primes up until that number. And let's just return the number for now, and then I'm going to console log sieve with, let's say, 10. And let's double tap that this actually works. And it does. Cool. Okay, so what is the strategy here? The first thing we want to do is make an array with numbers up until the number specified in the sieve function. So I'm going to come in here and just make an array. I'm going to run a for loop. I'm going to say I equals 0. While I is less than or equal to num, I want to increment I. And then I'm going to push whatever value I is into the array. And then I want to return the array so we can see what's in there. Okay, let's run this. Cool, you can see I am basically outputting every number from 0, starting at 0 up until 10. That's what we want. It's worth mentioning that I'm using less than or equal to, because if I just did less than, like this, I would stop one short of number, but we want to include the number as a potential candidate for prime. So that's why I am doing less than or equal to. So if I was just to run this code, for instance, I got 0 up through 9, but I actually want to include 10 because I want to check if 10 is actually a prime or not. So let's do less than or equal to again. Okay, so I need to make another array to capture all of my prime numbers. It's just going to be a bucket for my primes, so I'll call it primes. Now my next line of business is I'm going to loop over the array we just created, and I need to check, is this number a prime number or not? If it's not, then I'm going to set it to false. Okay, so I'm just going to make another for loop. Notice again, I'm starting at 2 because 0 and 1 are never prime numbers, as we've established before. And then I'm going to just set I less than equal to array.length and then increment I. This will ensure that every element in my array is hit and checked. Okay, so if array at I does not equal false, then I want to push it to primes. Okay, So that's easy, that makes sense, but how am I going to determine which value is not a prime? So the way I'm going to do that is every iteration of my for loop, I actually need to run another for loop, and I'll set j equal to I plus I. So why am I doing this? Because recall, when the function loops over the formula or the array, you start at 2. You start at that number 2, and then you go over 2. You don't just initially set 2 to a false value. You're actually going over to 2 every second number. Every second number is going to be turned to false. Likewise, if I was 3, then you wouldn't just say 3 is no longer a prime. You have to move every third number. So that is why I'm using j equals I plus I, because that will accomplish that task. Okay, so now that we have that established, I'm going to set while j is less than array.length, I'm going to increment j. What do you think I should increment j as? Well, shouldn't I increment it as the number that I is, or the array at index I is? Because remember, if the array at index I is 2, then I need to be hopping over 2 elements every time, because I want to find that second element, and remove it from candidacy. Every second element, right? Likewise, if it was 3, I want to remove every third element from prime candidacy. So I'm going to say j plus equals I. Okay, so if this is the case, I need to set array at j to equal to false. So this is going to set all those numbers that don't qualify as primes to false, and this logic is grabbing the ones that are not set to false and pushing them to the primes bucket. Now if I return the primes bucket, it should be all the primes up until the number specified, which is 10. So let's see. And that looks good. Let's do a larger number just to double check. And that also looks good. Okay, just to bring home this point, I know I tried to describe it, but sometimes it's easier to see stuff visually. So I'm actually going to hop over to Google Sheets. So just to visualize how I and J are happening, I have this thing pulled up. So we start at 2, and then I'm actually going to denote J with, let's say, this color right here, this pinkish color. And we start at J, or we start at I, and then whatever J touches, that is what we're going to declare as false. So start at I. So if we know that J is just I plus I, then we know that we should go to 4, right? So this is not a prime number, so I can set it to false. Let's set it to F, how about that? And then I'll denote it with the same color as J. So everything that J touches is false. Recall that we are incrementing by I in this for loop in here. So J increments by I, which we've said during this first implementation is 2. So 1, 2, false. 1, 2, false. 1, 2, false. Just like that. So I can just remove all 3 of these numbers from the pool of primes. And then now I'm going to repeat the process again. 2 is no longer the value of I, because recall, I'm incrementing I by 1 each iteration of the for loop. So this outer for loop, I start at 2, and then I'm incrementing just by 1. Okay? So let's change the color of this, because that's not the value of I. Now 3 is the value of I. So if J is just I plus I, then what is the value of J on this this row? Well, we start at 3, so 1, 2, 3. That's already been false. Perfect. Let's do it again. 1, 2, 3. Oh, we found another one. That's false. And we can just color that out. And then technically, you're right here. You're already done because you have 2, 3, 5, and 7, which are all prime numbers. They will never get deleted no matter how far you go. So that would be our answer. Obviously, if you had a larger data set, you could see more of this, but it would be kind of time consuming. I just wanted to illustrate how the value of I changes and how the value of j changes. Notice that j, starts there, then it increments by the value of I, and that is how you remove numbers from prime candidacy, and that is the Sieve of Eratosthenes function and formula. I hope you enjoy this video. Be sure to like and subscribe, and I will see you in the next one.